If I were to draw this, knowing that I have a right-tailed test and its critical value coming from the chart is 2.53. Here's the mean, 1 sigma, 2 sigma, 3 sigma. 2.53 would be approximately here. So that my chart value of 2.53 blocks off approximately 1% of my curve, the part I'm willing to be wrong. But when I calculate this, already done for you, it comes out to be 3.002 over here. The calculated value is 3.002. Well, you can see that you're going to reject the null. The calculated value is in the rejection region. But if I had to estimate what percent of the curve would still be behind the calculated value, truly just an estimate, I would say, oh, it's about 0.005. Less than that 1%, something less. In my next example, we're going to go with a left-tailed test, and here we're going to be dealing with t, so sigma would be unknown. When I draw that one, the mean, 1, 2, 3 sigmas, 2.81 is somewhere around in here. So my chart value gave me t, so it's 3 decimals. It's left-tailed, so it's negative 2.821. When I calculated that, already done for you, it became negative 1.762. So my calculated value so you can see that that's going to be in the fail to reject region. And then if I have to answer the last question, estimate the percent behind the calculated value, I've got to use the percent behind the critical value, the chart value first. In this one, alpha was given to be 1%. So if that's 1%, about what percent would be behind the red? So my calculated value. Well, since we know about the empirical rule, from the second sigma limit to the tail would be about 2.5%. So I'm going to guesstimate about 0.07. Let's go to another one. Here I'm going to be dealing with a chi-square because it is skewed to the right. It's dealing with k, which is the number of groups. Here alpha is given as 10%, and the critical value is 14.684. Somewhere around here. So my critical value, which comes from the chart, 14.684. That gives me a rejection region that takes a probability into account. A probability that is 10%. 10% of the curve is shaded. The calculated value here, already calculated for you, 16.572. And you can see that that is in the rejection region. If I had to estimate, to finish this question, the percent behind its calculated value, well, if from the black line is 10%, I'd guesstimate about 5%. Last one before we tie it together. If I'm again dealing with a chi-square because I have k's, alpha is 5%, the chi-square chart value is 9.488. Somewhere around in here. So my chart value based on number of groups and then degrees of freedom says that about 5% of the curve is shaded. I'm willing to be wrong 5% of the time. I go to my calculated value and it's 7.111. Somewhere in here. You can see that it is in the fail to reject region. And then the last question here, estimate the percent behind the colored value. So if I had to take this all the way to the tail and estimate how much would be shaded in red, well, if the black line gives me 5%, I would say that this would give me at least half of that. So let's say just a nice easy 10%. Purely an estimate. Now let's go back to the beginning and tie it together. Not looking at critical and calculated values to get the rejection region, but let's look at alphas and my estimate. This estimate would be the probability or the percentage of the curve from my calculated value back. If that probability is less than alpha, I reject. If the probability is less than alpha, probability, that's from my guess. It's actually the probability or the percent of the curve from the calculated value to the tail. If that value is less than alpha, then I'm going to, in this case, reject. In the next one, we've got critical from the chart and calculated. Here I can see it's in the fail to reject region based on critical chart values and calculated values. But if I were to use the percentages, the probabilities, here the probability, my guess, if you want to call it that, the probability, which again is really from the calculated value to the tail, and that in this case is more than alpha, I fail to reject. I'm in the fail to reject region. Let's finish them with the chi-square. This is obviously in the rejection region, from critical value to calculated value. But if my probability from the calculated value to the tail, in this case it was 5%, it's less than alpha, which was given at 10%. And what did I wind up doing based on the picture? I rejected. And on our final picture, here we're in the fail to reject region, and in this case our estimated probability from the calculated value to the tail, in this case it was 10%. We estimated it, but that's what our estimate was based on what we had shaded. It happened to be more than alpha, which was 5%. And what region were we in? We were in the fail to reject. So back through one quick time. The probability was less than alpha, we rejected. The probability was greater than alpha, we failed to reject. If the probability for our chi-square was less than alpha, we were in the rejection region. And if the probability was greater than alpha, it turned out we were in the fail to reject region. So here's the big rule. If the percent, which is called the p-value, behind your calculated value towards your tail, if that happens to be less than alpha, then the calculated value will fall in the rejection region every time. So you don't have to do calculated values anymore. Woo-hoo! If p is less than alpha, and this will be given from an Excel printout, if that's less than alpha, your calculated value would have to fall in the rejection region. Therefore, reject the null.